If you're going to solve by graphing, I mean, if you did this in Algebra 1 and you remember doing it in Algebra 1, you probably graphed the lines by hand, and then you looked to see where they intersected, and you estimated from the graph. And because straight lines are pretty easy to draw pretty accurately, you were mostly right. But when we start dealing with systems of nonlinear equations, of circles and parabolas and ellipses and all kinds of different stuff, it's not likely you're going to draw them so accurately that you could read it right off of your hand-drawn graph. You're probably going to solve the equations for y and put it in the calculator and let it do its thing. So that's what we'll do, even with this basic linear system, which we really don't need to do it, but it's a good example of how to do it. So I would have to solve both of these for y as the first step, right? This one is y equals 4 minus x. This one is y equals x minus 2. That's what you put into the calculator. So let me put in 4 minus x and x minus 2. And then I'm going to graph and look for the intersection points, right? And how many intersection points do we see? Got a cell phone or something? Take it off, or turn it off, or do something. Right. Okay, now the calculator will find that point for you. Again, when we get to more complicated graphs, you probably just want to do it in the calculator. These are the steps for that. That's what these are saying right there. You're going to go second trace, which is calc, and then 5 for intersection, and then we have to go through, like we usually do with left-bound, right-bound guess. For this, it's first curve, second curve guess. So here's what it looks like. Second trace, and you see number 5 is intersection, so 5. And when it asks you for first curve, it just means the first graph, because not all graphs are straight lines, some of them are curved, right? So first curve, and it's blinking here, and it says 4 minus x, so if we're happy with that being our first curve, and there's no reason we wouldn't be, we just say enter. And then it jumps down to the other graph, it's blinking on that, and it's saying second curve. If we're happy with that, we say enter. And when it says guess, say sure, go ahead, guess. And it should pop right to the intersection point, 3, 1. Right? So those are the steps for solving it that way.